Module 5, Part 2, Multiplying and Dividing Rational Expressions. There's only one objective in this part, and at the end of this objective, you should be able to successfully either multiply or divide rational expressions based on the problem that is given to you. So I'm going to model this process step by step, and I have listed the steps over here. So please follow along and write down the notes exactly like I do this, because I need to see this in your work as you're doing this independently. If I was going to approach this, first I would read the directions. It says simplify each and state the excluded values. So to simplify it, I need to follow these steps again, and it begins with step 1, factor if necessary, then rewrite in factored form. And then after I do that, I state these excluded values from factored form. And then to continue the simplifying process, I cancel out like factors, step 3, and then finally, step 4, I write what remains in both the numerator and denominator. So, the first thing I would do in number 1, if I was going to look at it, is I have to consider, are there pieces of this multiplication problem that need to be factored? Because again, I need to get it factored so I can state the excluded values in the denominator. And the way I think about this, if I was analyzing this problem and thinking about the pieces, that's how they go together, I would look at that there's 4 pieces. There's a top left one here, a top right one, a bottom left one, and a bottom right one. And that's how I'm going to be referring to these. Now, what pieces need to be factored is the question I'm asking myself. And it looks like there's 2 that need to be factored. The top right one, the number 1, does not need to be factored. It's just a number. The bottom left one, x minus 1, also is already a factor, so that doesn't need to be factored. So that leaves me this top left piece, the numerator over here, 8x plus 32, and this bottom right piece, x squared plus 6x plus 8. Both look like they potentially could be factored. Now again, this is going to call upon your knowledge of how to factor expressions, and so I think there's 3 types of factoring that we practice: greatest common factor, MACAB T-chart, and difference of squares. In this case, let's work with the first one. I'm going to show you my math for the first one. 8x plus 32. Because again, I need to get it into factored form eventually, according to step 1. Right now, it is not in factored form, it is in expanded form. I'll write it up here. Expanded form. I need to take it from expanded form to factored form. So, this 8x plus 32 doesn't look like 32 is a perfect square, so I can't use the difference of squares. MACAB T-chart needs 3 terms. There aren't 3 terms, there's only 2. And so in this case, it's finding the GCF. Now, to find the GCF, again, I look at the biggest number that is in common between 8 and 32. I can do a factor tree if necessary. If your brain can jump to the number immediately, then go for it. If not, then I need to see this side math before I can answer any questions. 8 breaks down into 4 and 2. 32 breaks down into 8 and 4. 4 breaks down into 2 and 2. 4 and 2 for the 8. 2 and 2, and then 2 and 2. Whole lot of factoring, but it's prime factorization. Now I look for the biggest number that's in common. I see they both have 4s, but please don't make this mistake. 8 is on the left hand for the number 8, and 8 is also in common with 32. And so 8 is my GCF for the numbers, the greatest common factor between the 2. Now, next I have to consider the x's, but in this case, there is no x that's in common because 32 doesn't have an x. So now I have found my GCF 8. In this case, then, I have to continue by rewriting it in factored form. So in this, I have to take the first term, 8x divided by 8. And again, if you need that process to be spelled out a little bit more, you can do side math. 8x over 8 equals, the 8's cancel out, I'm left with x. So that goes in my first part of the binomial, x. And then I take the second term, 32. 32 divided by 8 equals 4. It's a positive 4, so I put plus 4. So this is now 8x plus 32 has now become my factored form of 8 times x plus 4. Please keep that in mind because when we rewrite it in factored form, I'm going to use this now. Now let's move on to the next piece, the x squared plus 6x plus 8. And this is going to get to be the same process, except for now I have to consider x squared plus 6x plus 8 looks to be a trinomial, and the leading coefficient is 1. The a term is 1, so that means I can use MAC-AB. So I'm going to show side math over here. MAC-AB. So my MAC term is 1 times 8, which is 8. My AB term, the B term, is 6. So I need factors of 8 that add up to 6. I can start with 1 and its partner. 8 divided by 1 is 8. 1 plus 8 is not 6, though, so that doesn't work. Go on to 2 after 1. 8 divided by 2 is 4. Now, 2 times 4 is 8, and 2 plus 4 is 6. So I have found my factors for this trinomial. I have an x plus 2 because the 2 is positive, and I have an x plus 4 because the 4 is positive. So this is the factored form of this trinomial. So the first step is probably the longest and most important because I needed to factor, and now I need to rewrite it in factored form. So please label your factored form so I can see that. Factored form. My 8x plus 32 became 8 times x plus 4, so that's now my top left piece. My bottom left piece, x minus 1, I did not touch, so I'm just going to bring it down and rewrite it. Now it's multiplication, and then my 1, the top right up here, I didn't touch, so I'm just going to leave it there. And then finally, my x squared plus 6x plus 8 became my two binomials down here. X plus 2 and x plus 4. All right, that is step 1. I am done with step 1. Step 2, state the excluded values in factored form, and again, excluded values exist in the denominator. So for this, I've already done a pretty extensive explanation on excluded values in a different video, so if you need to, please go back and watch that video. But I'm going to label excluded values for my step 2. And the first thing I think about, how many factors exist in the denominator? And again, factor is something that has an x, or a variable. Just a variable in general, it doesn't have to be x. So I see that there's 1, 2, 3 factors. So that's going to tell me that there's going to be 3 excluded values that exist in this rational multiplication problem. So I'm going to start with this factor, x minus 1. Again, the thought process is I need to exclude a number that makes the denominator 0. So there's 2 ways you can think about it. What number can I put in for this x here to make that factor 0? And if whatever number that is, I can't include it because if you have 0 in the denominator, it makes this not work, this rational expression multiplication problem. So I can set this equal to 0, x minus 1. I could add 1. So x in this case can't equal 1. Because for this factor, if I put 1 back in for this x, 1 minus 1 is 0, and again, that doesn't work. Over here, I can do x plus 2 equals 0. Subtract 2, subtract 2. So x can't equal negative 2 for this factor. And then finally, for this factor, down here on the bottom, x plus 4, x can't equal, hopefully you guessed it, negative 4. I could show my math, but hopefully you can see that if you just set it equal to 0 and solve it, instead of being x plus 4, it's going to be x can't equal negative 4. Because if I put negative 4 into this factor, negative 4 plus 4 is 0, and having a 0 in the denominator makes this not exist. So that's step 2. I have found my excluded values right here. Hopefully, again, if you can, for that step, you need to be able to identify how many factors exist in the denominator, and then think to yourself, what if I put a number into that factor, or that x in that factor, what would make that 0? And then I have to exclude that number from my rational expression, or the simplified form of it. So I'm done with step 2. Finally, step 3, canceling out like terms. So for step 3, I venture back to factored form as well, and I will do this in blue. Like factors, canceling out like factors. I need to identify factors. And so, in this case, I have an x minus 1 here, an x plus 2, an x plus 4, and then an x plus 4 on top. If a factor exists on the top and the bottom, I can cancel it out. Because technically you're dividing it by itself, and anytime you divide it by itself, it equals 1. And I can say it cancels out, or I can write 1, but you don't necessarily have to do that. So in this case, x plus 4 on the top and bottom cancel out. There is nothing else that is in common on the top and the bottom, or in the numerator and the denominator. So I am done canceling out like terms, or like factors, I'm sorry. So I'm done with step 3. This was step 3, canceling out like factors. Finally, step 4, write what remains in the numerator and the denominator. So in step 4, again, step 4 might look differently depending on what remains after you do the first 3 steps, but this is generally what it should look like. I have an 8 right here, and I have a 1 right there in the numerator, and they're being multiplied on each other. If there's numbers that are free like this, and I actually do that math, 8 times 1 in this case is 8. And it's going to be over then. I have an x minus 1 right here, and an x plus 2. And please leave that, you don't have to multiply those together. Please leave it in factored form. So I have x minus 1 times x plus 2. And in this case, I am done. So, step 4, this paired with my excluded values is my final answer. And this is what I need to see. So please lay out those steps 1, 2, 3, and 4 exactly like I did it so I can visualize and see your work as you're working as well. And again, please be reminded that in step 4, sometimes it won't look exactly like how I did it. Like, if this 8 in the numerator here and there was like a 4 in the denominator, then I would actually divide 8 divided by 4, and that would give me 2. So just be aware of that. Now, I'm going to have you try number 2. Raise your hand when you're complete so I can check your understanding. If at any point that you get stuck on one of these steps, please, please, please raise your hand so we can come talk about it, because it is very important that you master all 4 of these steps to be successful with this skill. And again, the only difference in number 2, I need to make note of this before the video is ending, is that instead of multiplication, it is division. So there's one rule you have to follow with division. Let's go back to a simple rational expression like the factor or fraction 3 over 4. And I'm going to divide that by 2 over 3. If you remember the rule from elementary school, you can turn division into multiplication and multiply it by the reciprocal. So I need to multiply 3/4 times the reciprocal, and that just means you flip it. You can hear, you'll hear me say that a lot. You flip the second fraction to, instead of 2/3, now it becomes 3 over 2. So I turned it into multiplication by multiplying by the reciprocal. So it's the same thing down here for number 2. I don't do anything with the first rational expression, so I'm just going to rewrite that again. (48a). But in this case, instead of division, I'm going to write multiplication, and I'm going to flip the second fraction, or multiply it by the reciprocal. So it becomes 6a over a minus 4. So when you're doing your practice and your homework, anytime you see division in any of these problems, you would turn it into multiplication and you would multiply by the reciprocal, just like I did here. I multiplied down here by the reciprocal. So go ahead and try number 2, and then raise your hand so I can check your understanding.